Hello and welcome to Golden Geography. Today we are going to be thinking a little bit about the Earth's life support systems for OCR Geography A-Level. And we're going to be focusing on key question 4, which is looking at the question, to what extent are the water and carbon cycles linked? So we're going to think a little bit initially about those links and how they are interdependent on each other, but then also how we can manage them, how we can tackle some of the problems and issues that we've seen throughout this unit. So we'll start with the question, the two cycles are linked and interdependent. Well, the best thing to do is to actually just sit down and do a little kind of mind map or Venn diagram, or as we have here, just pick out key parts of our Earth system, like the oceans or the atmosphere, and think a little bit about how they're linked, and then annotate it. So if we think about our oceans, we do get carbon in our oceans. We get it diffused from the atmosphere into our oceans. So we have a source of carbon that way. It is also in our oceans through being carried by rivers in the form of sediment into our oceans. Therefore, we have carbon in the oceans, but our oceans are also fundamentally water. And then we need to think, well, how do they interact within our oceans? And really we're thinking about the biosphere here. So yes, we can take this down to vegetation, and we can look at seaweed and potentially even things like corals that would use carbon and water. But also we can think about all the vast array of different fish, of whales, of sharks, of squid, of octopus, all the things that live in our ocean that use both carbon and water. And not just live, but also decay. Once they have died, these animals will die and add carbon. And we end up, particularly if we're looking at our zooplankton and our phytoplankton, we end up with a lot of marine snow. And that marine snow will settle to the bottom of the ocean, where we can get carbon stores. We can do the same for the atmosphere. We can think about the carbon in our atmosphere, the gaseous state that it's in, the different layers of our atmosphere where we get very high concentrations of carbon, the different forms of carbon we might have, CO2 or methane within our atmosphere, and how that might interact with water, particularly where it does interact, potentially acidifying water, so leading to acid rain, and what that might mean in terms of precipitates of both water and carbon. We have our cryosphere, so areas of ice. Ice can trap both water as a store, but also carbon. We get bubbles, air bubbles within the ice, a bit like you get air bubbles in an Aero chocolate bar. Those air bubbles trap carbon from the past, and that's how we can work out past climates. And of course our vegetation has both carbon and water in them. So how are they linked? How are they dependent on each other within those systems? So try a mind map. Try and develop as many different branches off that as possible about how these two are linked together. Well, we also need to think a little bit about how our activities are changing what is happening in the water and carbon cycle. So if we think about carbon, some of the main human activities at play in these areas are urbanization. We now have more than 50% of the world's population living in urban settings, whether that's big cities or even just growing towns, and some of these towns are in quite rural areas, but this process of urbanization is ever growing and expanding, and that growth in population needs to be fed. So farming and farming techniques are trying to develop and are changing the carbon cycle. And alongside that, forestry. We have big issues with deforestation that are or areas of land that's being deforested to clear to enable farming. So carbon cycle have those key areas. And if we think about the water cycle, we're getting aquifers and artesian basins are areas where water is stored, and we are extracting water from those areas primarily to meet demand by human beings, whether that is for agriculture and the production of food, or for washing or drinking. There are big issues there, and some of these are overlapping, but the cause is our human activities and our human demand for them. If we think a little bit about climate change, it is impacting our oceans, our biosphere, our atmosphere, and all of those are places where we have water and carbon. So water to start with, we can see, if we look at long-term changes to climate, well, potentially that is going to mean that if we've got warmer climatic conditions because of climate change, then we're going to get increased evaporation. We're going to have greater temperatures leading to greater evaporation. And when those temperatures get warm, we have much faster rates of evaporation. There's much more energy in the system. So we're going to get a much more intense rainfall, much more intense storms. There are parts of the world that are experiencing thunderstorms, but then that they haven't before. That shouldn't be happening because we are getting warmer. Some areas, like the UK, will get wetter. Some will get drier, and those patterns have been predicted, not always accurately, but there are definitely climate models looking at areas and how they're going to change and alter, how those climatic patterns will then influence the biomes we get to. Going to get much more frequent storms and much more violent storms as well, much more extreme weather. And in some areas we're going to find that we're going to lose stores, traditional stores of water, particularly our glaciers and our ice sheets will melt, releasing fresh water into the system. So what once was locked up in a store might now start moving really quite quickly through it. There's a little video down the bottom here that you can look through. You can see some of the changes happening here. Increasing evaporation, warmer atmospheric conditions, more intense rainfall. So just a brief explanation there. We also have long-term impacts on our carbon cycle. So the natural climate cycle, some of those natural processes, the process of growth, the process of decay particularly, are changing. So in an environment in which you have a lot of carbon in the atmosphere, carbon is really important for growth of plants through photosynthesis. They can draw down that material that they need from the atmosphere, which means actually plants will have a greater source of carbon. They can grow more, they might be able to grow bigger, they will certainly be able to grow in areas they might not have done before. So we may see changes in the amount of net primary productivity and the amount of biomass that we have, which would be good, would be positive, and it might help with some of the feedback loops and systems that we see at play here. It might help get carbon out of the atmosphere. Hopefully we will see an increase in vegetation across the globe. We might find in areas where there is extreme heat and extreme dryness that actually those areas might become dry and barren. We should also find that if there's extreme levels of growth, that there's more biomass, that actually there'll be more decay, more decaying matter. In warmer conditions means that decomposition and decay will happen quicker, particularly in warmer and wetter environments. Okay, what about the implications for managing the water and carbon cycle? What can we do to reverse some of the problems that climate change has generated and human activity has generated? Well, first of all, if deforestation is a problem, then afforestation is the solution. There are a couple of examples where this has taken place, but one of the best ones is in China. They have developed something they call the Great Green Wall, and they are actively planting large amounts of biomass, large vast swathes of trees to mainly tackle soil erosion, to prevent areas that are very dry, that have a loess material, which is very lightweight soil, to prevent that from being eroded. And they have this massive scheme in place, and where it has been put into place so far, it has been massively successful. The United Nations has a scheme as well, the Reducing Emissions from Deforestation and Forest Degradation scheme, trying to incentivise, help countries to put in plants, to put in trees, particularly this afforestation process to try and tackle. It's good, but if you plant a tree today, it could take years, decades to really fully establish and to therefore the effects to take place. So it's a long-term project. Well, what can we do in terms of our wetlands? Wetlands are quite unusual. You don't really think of them in the way that you think of a rainforest, but they do the same thing. They're really good at capturing both water and carbon and storing them. Unfortunately, us human beings like to drain them because we want that land, we want to use that land to live on it, particularly for agricultural purposes. And there are some parts of the world, the US particularly, where wetlands have halved because of human activity. Well, many of these wetlands are designated, they have Ramsar designation, particularly here in Europe from the European Union, and they're trying to restore and protect wetlands. So here in the UK, they're trying to restore 500 hectares of wetland, put them back into place. And many of this is happening in the east of the UK, the kind of Norfolk region, but you do find some a little bit closer to home, areas that might just be very small, where a river runs through and they're trying to build up that river to enable it to flood and to have areas of flooded wetland around. Well, what about agricultural practices? Here we have big challenges. As human beings, we rely on agriculture for the production and provision of our food. And as our population has grown over the last 100 years, 200 years, from 1 billion to 7, 8, 9 potentially billion people, we have to feed people. And people's dietary expectations have changed as well, and the amount of food that they consume. So there is pressure on agriculture to provide food for people, which means technology has been really key in driving food production. But technology and that need for high levels of production has actually very often had a negative impact on the soils, on the carbon in the soils, on the nitrates in the soils, on the water, and our soils are exhausted, which means, yes, we can feed ourselves today, but in maybe 20 years or 50 years, our soils won't be able to provide us with the food we need. So we need to think a little bit about our soils, what we can do to protect them, to enable them to capture carbon and water, to help them regulate our climate, our Earth's climate. So there is something called regenerative agriculture. It's actually something Marks and Spencer's have started to get behind, so you see it mentioned in their adverts. And the idea of that is you don't till, you don't turn over the soil because you're disturbing the soil. By disturbing the soil, you're kind of losing some of the key components that make it stick together, that make it nutrient rich. We do something called restorative agriculture, which is basically a combination, no monocultures. Monocultures are bad. You end up having big problems in terms of disease and pest control if you have a monoculture. If you have diversity, that is beneficial. And if you have specific types of plants, particularly potatoes and beans, that store nitrates within their root systems, that benefits the soil. And also we need to think a little bit about the livestock that we have and what they do to the soil. What are we feeding them? What are we growing to feed them? What other things can we feed them that has less of an impact? And also using them. We don't want to get rid of livestock. I'm not saying everybody has to be vegan. We need our livestock. We need their poo as a natural fertilizer for our soils. So we need to think a little bit about how we do this, what we eat, where we get our food from, and how we can make it a little bit more sustainable. The other thing is a little bit more tricky. If we're trying to target carbon particularly, then we need to think a little bit about carbon credits. These have been around for about 20 years or so. They were established to give both countries and industries a credit limit, whereby hopefully once they reach their limit they would stop emitting carbon, or if they wanted to buy extra credit they had to then invest in green activities, whether that was afforestation or green energy. The problem with this is there's been a little bit of mismanagement, inflation of the credits. So it's a nice idea. The practicalities of this on the global scale have been a little bit difficult. We also have international agreements. So the Kyoto Agreement was key around about the turn of the century, and that particularly led to things like the carbon credits. And every year we have a climate meeting, and one of the most important ones was the Paris Climate Agreement, where most countries agreed to limit global changes, global temperature changes particularly, to less than 2 degrees centigrade. Really we need it to be 1.5 or less. We're already beyond 1. If we start getting higher than that, our climate and our environment, our biosphere will change beyond recognition. So the Paris Agreement was important, but it was an agreement, it wasn't action. And that's the tricky thing. Do have a look, do a little bit more research into the Paris Agreement. Maybe look at the Kyoto Agreement as a bit of background to help, but certainly look into the Paris Agreement. We also need to consider how we protect our water, what we're doing with forestry, and how we consider our links between the water and carbon cycle. So the UN, World Bank and other organisations are looking at forests not just as a store of carbon but as a way to protect our water cycle. So thinking about sustainable forestry. And we can see here that Brazil has received money to really think more sustainably about the rainforest and what we're doing in terms of accessing, using it, supporting that country, that economy, but also protecting the water cycle and the carbon cycle in that environment. We need to think about how and where we use water. So is having a shower every day too much? Do we need to use water-saving devices, or just not flush our toilets? Maybe flush the toilets once a day. Water butts in our garden. What practical things can we do? What can industries do? What can governments do? To think about how and where our water is used. Agriculture and industry take a lot of water, but we need those for our economic activities. So how can we regulate and improve the use of water in those environments? What are we doing in terms of using our water, where it is, our rivers? We have talked briefly before about the investment of the EU. Unfortunately, a lot of that has been limited or even stopped post-Brexit, but the Environment Agency here in the UK has taken over many of the things that they were working with or investing in. And within the New Forest and other parts of the UK, we have this rewilding scheme that's taking place, where we're trying to reinstate wetland areas and meanders, get Expo Lakes areas to develop, partly to prevent flooding of urban areas, but also to increase water storage. So if we think about how we manage our rivers, potentially how we're managing our artisan basins, our aquifers, what we're doing with them, then maybe we can use our water in a better way. But we do need to think both nationally, but also internationally as well. What are we doing to our water supply? How does that affect other countries around the world as well, the movement of water?